Integration involving inverse trigonometry. Here I have the revision of trig differentiations. This will be important for the next few slides, as today in this presentation we'll be learning how to take the 1 over root 1 minus x squared back to the sine inverse, and the same for cos inverse and tan inverse. So integrating to get inverse trig. So this is the general form of integrating 1 over root a squared minus x squared dx, which will become sine inverse x over a plus c. So the domain for sine inverse is minus 1, 1. So when we have a, we have to make sure that x is not greater than a or less than minus a, as in the fraction will be outside the domain. So for cos inverse, it is pretty much the same as sine inverse, except the top now is a minus 1. And for tan inverse is a bit more recognizable, as the bottom is not a root, but the top is positive, and it is a squared plus x squared instead of a squared minus x squared. So this is our first example, integrating 1 over root 4x, integrating 1 over root 4 minus x squared. So the top is positive and the bottom is a root, therefore we can conclude this is sine inverse. So we have written down the general form for this integration. So now we recognize that 4 is our a squared, so we square root that, so we can get a equals 2, and then we plug that back into the formula and replace a with 2 to get sine inverse x over 2 plus c. Example, integration of minus 1 over the root of 9 minus x squared. See, here we see the top is negative this time and the bottom is still a root, so we can conclude the answer will be a cos inverse. Here I have the general form again. Now we look at 9, which is our a squared, and then we take that and get a equals 3. Now we replace our a with 3 in our equation, so we get cos inverse x over 3 plus c as our answer. So this is our next example. So we see here the bottom is not a root and the top is positive, so we can recognize that this is a tan inverse. So remember, for tan inverse, we also have to put 1 over a at the front. So here we recognize that a squared equals to 4 in this example. We square root that to get a equals 2. And now we replace all the a's in this form with 2, so it becomes half times tan inverse x over 2 plus c. Now, so our next question and our last question for this presentation is integrating 2 over root 3 minus x squared. So this might be a bit harder because the top is not a 1 and is now a 2. So we see here the top is positive and the bottom is a root, so we can conclude this is a sine inverse. However, in this example we see the top, unlike before, is a 1, but don't panic because we can just move the 2 to the front, and so we can take it out and the top will just become 1. And we also have to times 2 to the sine inverse here. So next we just follow the regular steps. We see the a squared equals to 3. Therefore we can say that a is equal to root 3. Then we replace the a with root 3 to complete our answer of 2 times sine inverse x over root 3 plus c. So here I have an exercise from New Senior Mathematics NSW Maths Extension 1. It's 11.8, where you can practice what we've learned in this presentation.